Hi, this is Ari Helchak from Root Signals. So today I'm going to cover some really critical topics to building any LLM automations. So whether you're building applications in the form of agents or chatbots or just background workflows powered by LLMs, what you need to solve is how do you actually make them reliable without human supervision. How do you optimize these automations for cost, latency, and quality? And how do you actually manage this whole thing in long term? And what I'm going to argue and explain in great depth is that almost nobody understands how complex this task is going to be right off the bat when you get started with building. And then you sort of start figuring this out one step at a time and realize that, okay, there's uh, one hurdle after another. And it would actually make your life a lot simpler to think these things through beforehand. So, how do you actually get to the point where you can build scalable AI applications in a way that is really under your control? So that's what we are going to be discussing. And the key to all that is to effectively use the second layer of language models to charge the first layer. So this is what we generally call the LLM judges, and this is going to be what you need to start controlling in a systematic way. And I'm going to walk you through all this. Our focus is going to be on LLM-based agents, but essentially almost everything that I'm going to cover is actually going to be applicable also to chatbots, also to any LLM automations, but not all of them require all this complexity, fortunately. So to start with, I'm going to explain like why are these evaluations of LLM based applications hard in the first place. And to reiterate, we are not talking about evaluating uh, evaluating the large language models in isolation, like in some kind of academic paper, but we're going to be evaluating your application performance from the perspective of how it's using these models. So the problems that occur in your application because you're using the language model, and those problems might be same or completely different than what you see in the academic papers. And then we are going to talk about how to optimize these evaluations, which turns out to be very non-trivial task, and we call this whole process EvalOps. And we are going to talk about agent evaluations in quite depth specifically because they are sort of the superset of all these evaluation needs that all these simpler uh, pipelines and simpler applications are also going to need. And then finally, we'll actually look at some practical examples, like how do you actually optimize, what happens, what do you gain, what do you lose when you start optimizing, how does that whole, well, what is that whole frame of thinking going to look like? So to exclude some things, our task today is not about agent building. It's not about uh, controlling the latency, controlling the agents, and it's not about minimizing the costs of running agents. And the reason we are not going to talk about these things is because these are handled by your agent frameworks, and we could call these like agent ops for lack of a better word. So there's going to be a whole different set of lectures on these topics, and they are quite dependent on which framework you're using for your agents, which framework you're using for building your LLM automation in the first place. And and instead, we are going to talk about how do you define and how do you measure the performance of your agent across all these multiple dimensions. And this is going to be covering, this talk is going to be covering this whole map of different things that actually pertain to the correct performance of your agent. And if you think fundamentally, why and how can this be this complicated? It's really, if you think back, like if I give you a knowledge work task, like what are all the things that you need to actually go through to determine if you're doing it correctly? You need to understand the task, you need to be able to communicate about the task, you need to be able to judge yourself if you're moving forward with the task. You may need to use various kinds of tools to accomplish the task. and you need to be able to review every part of your progress, every step when you move forward. So all these things we take for granted, but then if you give the same tasks to a language model, the task is not going to become suddenly simpler. It's going to be equally complicated, and that's why we look at all these different parts. And we are going to come back to this map and go look at it one step at a time during this talk. So our actual task today is to discuss how you evaluate the agent success, how do you align the agent performance, the agent behaviors to your expectations. We are going to discuss how do you actually manage the latency and cost of the evaluation process itself, because if you don't manage this, it's going to cost you so much to just do the evaluation that you're going to be unable to run that in a scalable way in real-time context. You're not going to be unable to run those evaluations frequently in the first place. And finally, if your evaluation results are not consistent because your whole evaluation methodology is not consistent, which is very usual when you use LLM judges, then of course those evaluations are not going to help you much, no matter how you set them up. So that consistency aspect needs to be addressed. And this all is what we call the EvalOps. And again, it pertains also to other LLM automation, and not only agents, but anything you build on top of large language models. So why is this so complicated, and what makes this different from traditional software testing? Well, firstly, we need to understand that you cannot assume that for some given inputs where you know what the expected answer is going to be, that you can use that sort of methodology to drive to test these behaviors of agents in these open-ended setups. So if you have a chatbot, you have no idea what the user is going to ask. So how can you possibly build a system that will be based on just your expected inputs? You can try, but it's never going to cover the real-life situation. The even worse situation is with agents, because the agent is going to run in an even more complex environment than just what the user was asking. But there could be other environmental factors that come into play. If you're coming from machine learning background, you might be thinking that you run some kind of generic benchmark set or some kind of test sets off the shelf, and that's again not going to cut it, because you need to look at these task-specific situations. You have some specific tasks that you want your agent or your chatbot or your LLM automation to cover, and some generic benchmark is not going to get you very far in evaluating how well that's going to perform. Another important frame of mind or mental model to take into account here is that when people think about what you can do with large language models, one of the primary sins is to think that, okay, I have seen that the LLM is capable of achieving this specific thing, but achieving that once, which sort of maps us what is the capability of the model, is very different from consistently running and achieving that same performance. So imagine if your application succeeds 90% of the time. And that sounds good until you realize that, okay, you have like 7 stages of that pipeline. And if it's every step fails 10% of the time, that's going to end up with a very poor outcome in the end, especially if it's indeterministic, and sometimes you get better performance, sometimes worse performance. So this becomes very quickly some kind of a testing nightmare. And the measures of success are also going to be very different from traditional software testing. So you're going to be looking at things like avoiding hallucinations. You're going to look at the semantic features of the outputs of the LLMs. That could include like relevance, clarity, conciseness, helpfulness, and such things. And you will be optimizing them against cost and latency, like in other software performance tasks. But it's going to look very different as a balancing equation between semantic performance versus these low-level measures of cost and latency. So it's a multi-dimensional optimization task. So You cannot really rely on humans or what we call the vibe checks. They are not going to take you very far when you try to automate the behavior of these things, especially for agents. If you just think that putting some basic guardrails there, that's not going to take you very far, because then it's only going to prevent some standard, most obvious failure modes, if even that. And also the similar situations with if you take some open source evaluators out of the shelf, you're going to have two different problems. One is that firstly, those evaluators probably are not sufficient to cover your use case. And secondly, if you get some number from those evaluators, so what does that number actually mean if you don't have sort of any kind of like a framework for actually playing around with those numbers and measuring the consistency of those numbers, etc. So there's this job to be done that you need to optimize for latency and cost. So you need to define what we call the objective, which is essentially what is the intended behavior of your automation. Now, an objective can be defined in fundamentally two or three different ways. So one is by defining the human understandable intent, as described here, like maximum human flourishing, etc. So you can give a very grandiose or very practical description of what is the task. Then in addition to this, you can define what can be called procedural definition of the objective, which is that we define exactly what kind of external evaluation algorithms are going to define the correct behavior of your automation or agent. And this is fundamentally what we are going to presume in this talk. There's a third way, which would be extensional definition, which would just be then defining your objective in terms of rigid input-output datasets. But as previously discussed, this is not going to take you very far. So actually, this extensional way of defining it will include this. We have to involve these procedural definitions, which then will mean that you need to run these LLM judge-based evaluations. So this brings us to this concept of EvalOps, which is essentially a subset of what people sometimes call LLM ops, which is a subset of MLOps. MLOps being how you train models, how you improve models. LLM ops being how you can operate these models effectively. And EvalOps is going to be how you judge the performance of these models by using other models. So all these things, all these different disciplines actually come out looking quite different, even if they are subsets of one another. And we are, of course, here just focused on the EvalOps, which arguably is a big enough topic in itself. So EvalOps means that you are building two different things. So you're sort of playing with two decks of cards. You have the actual operations that your agent or LLM workflow is going to carry out. And these are what we would call the operational skills. So something like your agent needs to extract metadata from contracts, for example. But then there's another layer, which is judging the operations, as judging the success of those automations. And this is what we could call the evaluations or evaluator skills, like checking if whatever the agent is saying, if it's going to adhere to certain policies. Now, when we come to the totality of agents and the performance of the agent, there's going to be different parts. So firstly, looking at what we would call the semantic quality, and this in itself, which is the left side of the map, is going to involve two parts. There's going to be single turn and multi-turn evaluations. So in the one-turn evaluations, we are looking at the properties of a single semantic operation, meaning something that the agent is saying, some kind of text that the agent is producing. So we are starting from these semantic estimates of or evaluations of those outputs from the agents. So this is like if you imagine a chatbot saying, just answering one question. You can evaluate its consistency, answer question relevance, etc. You can look at virtues that are specific to what you are trying to achieve, which would be, does the agent actually discuss things in a way that would be fitting your purposes, your business goals, etc. And finally, if you're using RAG systems, which is probably the majority of cases whenever anyone builds chatbots or any kind of knowledge-based agents, you're going to have RAG-specific evaluations. And there's this very nice picture which kind of outlines again, quite many complex ways in which different parts of the RAG pipeline actually can be measured. And this starts from looking at how well the context was retrieved, how is the context being utilized to produce the ultimate answer, does this involve hallucinations, which means certain kinds of certain kind of components in the chatbot's answer that were actually not there present in the reference data, and so on. So there's a number of different things that we can measure to evaluate if there are problems happening in the RAG pipeline. And these measures, of course, you can get from Root Signals platform and also from some other evaluation platforms, and you shouldn't code them yourself. So then we move to the semantic quality in the multi-turn context. This means that when you have end user and a chatbot taking turns in the conversation, and there are multiple such turns, or you have multiple artificial agents talking with each other, then you have what we call a multi-turn situation. And this means that you need to not only look at like one question, one answer, but is this conversation itself consistent? So you need to evaluate the complete conversation and not just like one answer, question answer pair. So quite often what we require in this case is also that the agent is going to adhere to the topic in a certain way. And we need to decide that do we allow the other party to actually change the topic or not. And importantly, when we talk about agents specifically, the agent is going to take reasoning steps, and we can also chart specifically the reasoning trajectory. Like, is it actually making doing that reasoning correctly? Of course, we might need a powerful model to judge that reasoning quality, but especially if your agent itself is powered by a small model, this is actually a very appropriate thing to also consider measuring. Then if you move into behavioral side of things, where we are now separating from semantic, where we were looking at the meanings of the text that the agent produces, and now we are looking at what sort of behaviors it exhibits, in addition to, of course, producing the text that we were just looking at. So now we are talking about the use of tools to achieve certain ends. And for agents, a tool is anything that any kind of external software process or entity that the agent or algorithm, whatever, that the agent can invoke. So this could be like reading a file, writing a file, making web calls, making SQL calls, and so on. So we need to look at various qualities of what constitutes the correct performance in this tool orchestration. Firstly, calling the tool in the right way, being consistent, and of course accurate in your selection of the tools. And then there is the handling of the tool outputs. The low-level error situations with the tool usage, like inability to read a file due to the lack of correct permissions and so on, those things are handled by traditional software design principles. But the way in which the agent then is going to be recovering from those situations, that again it becomes like a very agent-specific, very AI engineering specific problem and question. And then, of course, you may still have to evaluate the outputs of those tools, which actually makes it very interesting from the general way of how do you evaluate software outside, like using the same methodologies outside LLM agents, but that's a special case then of this general case. And finally, we also have the multi-step situation for the behavioral side. So when your agent is carrying out complex tasks, it's going to go through several steps, and there's a question of how well do you decompose your tasks, your main task into individual step in the first place. Are you making progress when you take those steps? Are you converging towards your goal? Can you ever measure that? Maybe you can, maybe you cannot, but there are certain cases where you can measure that. And ultimately, is it going to be aligned with the goal that you have? And if it's making some kind of plans, you can actually evaluate the plans before you take those steps as an agent. Now, finally, all these is actually going to be grounded, fortunately. So there is an objective side to all this. So the semantic side is going to be grounded on faithfulness, which is essentially the adherence to your reference documentation, and factfulness, which in this definition is just whether the statements that the agent does are factual in the wider sense of the word, which might be beyond the reference documentation, but it's happened to be true. So it's a difference between, like, does the agent only talk about things that are in your provided information reference, or does it also answer the questions about culture and countries and science in general and whatever, global knowledge. And you can, depending on what you're doing, you might be interested in one of these, but there's no universal rule to say which ones you should be using. It depends on what kind of application you're building. And similarly, on the behavioral side, you're going to be interested in whether the goals of the agents are actually being achieved. And this requires some reference to the actual external world. The behavioral side is ultimately grounded in the tools that are available, and the semantic side is ultimately grounded in the data that is being provided to the agent. There's a bunch of practical considerations. So you have this cost and latency optimization that needs to be taken into account. There's a lot of tracing and debugging that you may have to do, managing actual practical error situation. You have to distinguish between offline testing, so which evaluations you can afford to run offline, which you can afford to run online. And then there's there's various extensions to these frameworks that we're not covering that relate to the dynamics of running an agent in an environment. So now we are going to dig into a few practical examples of how do you actually look at these different evaluations for real agents, real LLM automations. So let's look at first the semantic evaluation and then a behavior evaluation. So like we can take something semantic like persuasiveness. So how persuasive is the output produced by your chatbot or an agent? So it's defined in a way something like this. This is come from the root signals platform persuasiveness evaluator. So there's a big prompt that ultimately is going to power the persuasiveness evaluator, and there are models that can do this evaluation. So any LLM model could in principle be the judge that powers this evaluation. So now we are not going to look at how well your agent, how persuasive your agent is, but we are going to look at what does it even mean to make this measurement. So now, in order for this measurement to make sense, the question is like, okay, I'm getting 0.8 as an estimate of persuasiveness. So is it a high number or is it low number? What should I do with this? So you have to be able to define what kind of a grading system you have. What does it mean for, or the scale, grading scale? So what does it mean for 0.8 to be, what does it mean to be 0.8 persuasive? What does it mean to be 0.1 persuasive? Now we are using a scale from 0 to 1 here. So 0.1 should be something that is not persuasive at all, and 0.9 should be something very high, or 1.0, something super persuasive. So now you need to be able to define your calibration data set essentially, which means that what some or all of these different scores mean to you. So there are scores like 0.2 means which would be produced by, for example, the response that this book could be an interesting read for those who enjoy. So this is not very persuasive, but if your agent is intended to be persuasive, it should be giving very high outputs like 0.9. Invest in your future with our cutting-edge online course designed by industry experts, etc. So presumably this would be an example of a higher degree of persuasiveness. And now we are not going to discuss like how you make your agent to be more persuasive. We are just discussing like how can you even reliably measure this thing. And if we run different models to try to make these judgments, we get some interesting results. So let's take a look at this example where we are actually comparing different evaluation prompts for the same thing across different models. Comparing the same evaluation prompt across different models, like GPT-4o Mini, certain versions of Llama, and then we are comparing against Root Judge, which is the open weight model that was recently released by Root Signals for judgments, and then you have these various other off-the-shelf models. And we can see here that the models that deviate least from our calibration datasets in this example, which wasn't doctored at all, it was just the first run actually on this dataset, in this calibration dataset. So we see that actually the Root Judge and O1 preview were closest to how we wanted this persuasiveness be judged. So it means that these are closest to how we as humans have defined this specific calibration dataset. But now if we go forward, we can see that actually it doesn't mean that we necessarily should use these, because if we look at the model latencies, we also notice that these same two models that are best actually have the worst latencies. So depending on what you're doing, you might not want to wait 67 seconds or even 23 seconds. So maybe you should forget about these two models, and maybe you should look at these other models that are below 10 seconds, or even smaller ones if you really need to have it real time. And this is of course critically important. And now the next thing you want to look at is the cost. And you will find that actually Gemini Flash was the cheapest one out of these. So maybe all things considered, maybe you should take the Gemini. And now then looking at another evaluation example where you're looking at how consistent is the selection of the tool. So your agent is selecting tools to solve specific problems. So we want to see that, okay, how well is it actually being able to select the right tools for the job. And in this case, we just had a smaller set of calibration data. You probably would need a much longer one, but just for the sake of argument, we are defining that if the agent was expected to be using, for example, web search, and if it's expected to use a calculator for a certain problem, and it's actually using web search, this would be giving 0, and and the score of 1 would be if it's actually using the right tools for the job. So when it's given some numbers to calculate, it should be using calculator, and so on and so on. And then you have intermediate cases, because sometimes the tasks are not clear cut. So let's see how these models behave. So similar setup, we are seeing more variance here. So actually now O1 preview and Gemini seem to be weirdly far from what we would expect in terms of calibration. So let's keep this in mind and come back to this soon. And we see that GPT-4o Mini and the Root Judge are actually closest to what we were expecting in performance. But now, then, if we look at the latencies, again, O1 preview is super slow. Root Judge was a bit faster in this time, but also again, like these other models are much faster. And for costs, similarly, we have quite a lot of deviations. So we can see that actually Gemini is the cheapest one with only 0.002 per request for this. So based on all these assessments, we then need to do the selection. But in this case, we wouldn't be selecting Gemini because it has this huge deviation from our expectations. So we would probably be looking at these ones that have smaller deviations. So in running this, we might be curious, like, why and how are like O1 Preview and Gemini actually this bad with this? So let's dig deeper into this. So looking at Gemini 2, we can actually see that it was giving very high score, 0.75, so for something that we expect to be 0. So when the task was to compute something and the agent was, or at least in this test case, the agent would have used web search while it should have used calculator, the Gemini was for some reason still giving a score 0.75. So this doesn't make any sense. So it just wasn't able to do this judgment. And similarly, if we look at what was O1 Preview doing, there's the task again, the same task of selecting the calculator, which it in this case was happening in the right way, but it was still giving score 0. And also in this case where where the tool used was web search, where the expected tool was calculator, it was giving 0.5 when we were expecting it to be giving 0. So in this case, it was again going against our expectations. So this explains why these two models got such huge deviations. So the whole point of this exercise is to find which judge models under which sort of prompts are actually going to give us reliable judgments. So to sum up, the success of agents is very multidimensional. You need these charge-based evaluations to actually get this done, and the performance, latency, and cost of these evaluations themselves are highly counterintuitive. So you actually need to reserve time or resources and use the correct, sufficiently good platform and framework to actually build these judgments in the right way. So you need some kind of EvalOps framework to do this correctly, so that you save yourself a lot of trouble and actually can optimize these outcomes. So that's it for now. There's a final promotion at the end, so you can try out our platform for free. It will solve a lot of these problems for you. You can try out other platforms, but this is most specifically actually directed towards optimizing these evaluations. And we are continuously releasing new evaluators specifically for agents. So stay tuned, sign up, and try things if it works out for you. Otherwise, always happy to hear feedback on what works for you, what doesn't, and what you are actually building and what you need to get it done in the space of agents and LLM chatbots and workflows. Thank you very much. This is Ari from Root Signals, and thank you for your time. I'm now open for any questions.